Good morning, everyone, and welcome to session number 3, Beyond Big Data. We'll make sure you're in the right place before we get started. My name is Gilbert Palaio. I'm with Dynamic Systems. I'm an account manager supporting public sector, state, and local government. We are an Oracle partner and reseller of both Oracle hardware and software. Today, we're fortunate to have Brian Lee present the topic on big data. Brian Lee is a Master Principal Solutions Architect. I know that he looks kind of young, looks like he just graduated from college, but he's got 19 years of experience in the IT field. In addition to, along the way with the 19 years, he's been focusing on leading technologies such as virtualization, cloud, and today's topic, big data. He's got a lot of good information to cover, so I won't take any more of the time. I know we can be started a little bit late, so I'll pass it to Brian.
All right, thank you, Gil. So today we're going to talk about beyond big data. So it's kind of like people still have a fuzzy idea of what big data is, but what's coming after that, and how do you incorporate big data into your organization. So we have a little bit of housekeeping to take care of. This is Oracle's safe harbor statement. A lot of the slides today are my opinion, and my opinion alone, not necessarily of Oracle or of Dynamic Systems Incorporated. So the program agenda is a little bit of definition about what big data is, because everybody has a different definition. New and emerging data sources. So in the thumbnail that you guys read for this session, some of those were mentioned. And then how do you build a durable architecture that can absorb those new data sources and make use of them? And then we finish up with a couple of case studies. So this is a picture of big data, believe it or not. This cow is actually wearing a pedometer down here on its leg. And so what farmers, this happens to be a dairy cow in Germany, so it doesn't look like the dairy cows we have here. But what they've learned is that when cows are in estrus, they walk around a lot more. So this pedometer transmits to a wireless base station in the farm, and then that transmits up to the cloud. The data is processed, and it sends a signal back to the farmer's cell phone to alert them, hey, it's time to go impregnate this cow. So by doing this system, they've increased their insemination rates by 20%, which is great for a farm. But not only that, they've discovered that depending on the time you inseminate the cow, you'll get either a girl cow or a boy cow. And obviously, if you're in dairy farming, you're going to want girl cows. So they have a 70% accuracy of getting female cows by using this system. Before, it was just sort of random. So this is big data. This is another example of big data. This device is called the MIMO. And on this onesie, there's 2 green lines, and there are these little leaf things, which are actually sensors. And they collect lots of data from the child. So body temperature, movement, breathing. There's another company that makes something similar to this, will actually collect blood oxygen levels. I don't know how they do that. It's non-invasive, but they're able to do that. This company also creates a mat that measures many of these same variables of the child. So this functions very similar to the cow. This little, they call it a turtle thing here, is the transmitter. It transmits to something called a lily pad, which is their local base station. It goes up to the cloud. The parent has configured what kind of reports they want to get, and then they get alerts on their phone. So there's all sorts of data that is available for parents, how often the kid moves, if the kid is awake or sleeping, based on movement. If the kid is breathing. And the really interesting thing is that the company, MIMO, that has this device, they have access to all the data from all the parents that are using it. So now they can develop profiles of children's movements at night, or their body temperature, or their breathing, and they can start to correlate that with when kids are sick, potentially SIDS. So there's a lot of directions they can take this once they are able to gather that data. So the final interesting example here in the beginning about big data is Target. So everybody knows what Target is. Many of you in the room probably have a Target credit card. When you sign up for a Target credit card, they gather a little bit of information about you, and then they track all the transactions you purchase, all your purchases at Target stores. So Target hired a research analyst named Andrew Pohl, and he knew about economic psychology. And there was a study out of Duke University that looked at people's habits during the day. So 45% of your actions during the day are autonomous, meaning that you don't think about making a decision, you just automatically do that. And a really good example of that is when you drive home from work, you take a certain route. If your significant other told you to pick up some milk at the store, you just breeze past the store and you go home. Because you're on this habit loop, you just forget about it. So there are a few times in your life when these habit loops are susceptible to being broken or changed. One of those times is when it's a major life event like having a child. So what Andrew set out to do is to figure out, okay, if we can figure out when a woman is going to have a child, then we can start influencing her buying behavior. So maybe she doesn't buy, if she already has other children, maybe she doesn't buy diapers at Target. Maybe she buys them at Walmart. So how do we get that consumer to buy from us a greater product portfolio? So they developed all these metrics. It took them a certain amount of time. They also purchased outside data, so it wasn't only transaction data from Target. And the result of that is they're able to determine within a window of 2 weeks when a woman's going to have a baby based on her purchasing patterns. So the variables that tended to be the most important were things like used to purchase scented lotion, but now purchase unscented lotion, buying magnesium and zinc, buying lots of cotton balls. Those were all indicators of, predictors of, and based on the time that the woman purchased it, they can determine that 2-week window. So what Target then did was, okay, we know when a baby's going to arrive, so we're going to send out circulars and we're going to send out advertisements for products that they're not buying at Target, and hopefully we can change their habits so they continue to buy those products at Target. There's a cautionary tale that goes with this. When Target first introduced this program, they didn't think about the consequences. So those flyers that were going out to households, they stuffed it with lots of baby products. And so there was a household in the Midwest that had a teenage daughter in it, and the father saw all these flyers coming from Target and saying, why are there all these baby advertisements in the Target flyers? And he was very upset. So he didn't obviously know that his daughter was pregnant. He went to the store manager, complained, it went up the Target chain, and about 2 months later, 3 months later, he came into the store to apologize because his daughter had a baby. So Target has now changed how they use this amount of power. They'll throw in a lawnmower, a picture frame, something else to sort of randomize their circulars a little bit. But it's really cautionary, right? So when you get kind of this power with big data, you need to learn how to use it effectively. So the new and emerging data sources. The first one here is not really new. Most people know about this, but most organizations are not using it yet, which is social networks. You probably recognize Instagram and Facebook and all that stuff. And actually about 2 weeks ago, Facebook is probably not a social network anymore because people are not sharing personal information on there anymore. It's more of a media platform and an article sharing platform now. Below the line are micro social networks. They're very specific where people still share very intimate and personal information. So Athlinks down here on the bottom is a social network for athletes, so professional athletes that are trying to do bodybuilding or bicycle racing or whatever the thing is. Fishity is for fishermen, so they share what lure was good or what spot yielded the best fishing grounds. Doximity is for doctors. Some of you may be familiar with Nextdoor. I live in Roseville. The Roseville city does a really good job of using Nextdoor for communicating different things. Coffee with a cop, say meet at the Galleria Mall, and you can sit there and have coffee with one of the police officers from the city of Roseville. Waze, some of you probably know that. You can put in there, there's a cop around the corner at this intersection. Be careful. So that's kind of what we know today. This is kind of the future. This is beyond what we're doing today, really. This is the one I'm most excited about. It's called LiDAR. It stands for, it's an acronym from light and radar. And some agencies like DWR are using LiDAR already. Caltrans is as well. The picture in the lower right over here is the real picture that you'd take with a photographic camera or you'd see in real life. The picture in the upper left is what it looks like through LiDAR. And LiDAR you've seen on the Google self-driving cars or other self-driving cars around. It's just a small unit. It has a mirror and a laser in it, and it spins around really fast. And it shoots out lasers really, really rapidly. And then it times the reflection response. So if I shoot out and I shoot towards Gil here in the front, it's going to come back really fast. If I shoot out towards the cameraman and come back, it's going to take a little bit longer. So it develops what's called a point cloud of the environment. And there are LiDAR units that Caltrans is using in the Bay Area right now on 101 that can travel down 101 at 60 miles an hour and capture all of this data. It's a huge amount of data. So it captures not only where the LiDAR unit is in space and time, but it captures those reflections. And in this, which is kind of like a raster photograph, this pedestrian sign, I can't tell how far away it is from the building behind it. But in a LiDAR image, I know exactly how far the building is behind the sign. So there's another level of data that comes with this. And in the upper right here, this is an image of a mountain range that's enhanced with color. It's very low granularity, so it may not make a lot of sense. But this has certain use cases for natural resource management. You don't need a high level of definition to be able to understand if there have been landslides in areas, or if you're monitoring after a major fire happened, how is the landscape changing? So this is an image of BitCoin. It is not real. There's no such thing as an actual Bitcoin. It's a digital currency. So most people have probably heard of Bitcoin. It's a way for transacting. The technology behind this is called blockchain. It's a really, really cool technology, and it will be pervasive throughout our entire society. That's my personal belief. Goldman Sachs is already using blockchain to create algorithms to track documents. So during the financial crisis, a lot of mortgage documents were lost. So blockchain provides, through side chains and colored coins and other things that have been developed, a way to track those documents so they don't lose, who actually owns that house or who has a lien against it. And then more importantly for state agencies, blockchain is a very affordable or cheap way to do transactions. So if you're the DMV and you're doing registrations on a website, and people of the public are paying through credit card, you guys get charged like anywhere from 1% to 2%. Maybe you have a large organization, you can negotiate a cheaper rate. I think Costco had like a 0.5% with Amex before they got dropped. But with Bitcoin, it costs 1/10 of 1 penny for each transaction. It's very, very cheap. It's not a percentage. So if you're doing a car registration and you're paying, $500 and it's 1%, that's $5 you're paying to Visa or MasterCard or somebody. Wouldn't it be great if you could pay, 1/10 of 1 cent for that transaction? So for kind of friction in the digital currency, this has a lot of applications. It's much further out than the other ones, but it's very interesting nonetheless. So the final one is, does anybody in the room recognize this photo or where it's from? Yeah? I see a few nodding heads. So this is from How to Tame Your Dragon. And I put this photo up here because it's illustrative of a new branch of artificial intelligence, so AI. And this new branch, computers learn how to do a task. You train them how to do a task versus you having to write lines of code. So you're probably familiar with Tesla, and they released a couple months ago a self-driving mode where you can take your car down the freeway and kind of push a button and it self-drives. They have hundreds of thousands of lines of code to be able to make that happen. They acquire it from a company called Mobileye in Israel. And it's very expensive. It's very hard. It takes a long time to code, okay, if the LiDAR unit sees a stop sign, we're supposed to stop. If we see a pedestrian, we're supposed to stop. You know, you have to code everything that you can ever imagine, and it's very difficult. There's a guy named George Hotz, or Hotz, I'm not quite sure how to pronounce his name. He started in December. He bought a $30,000 car and $20,000 worth of equipment. 2 months later, he had his own self-driving car. One guy. So he did this through this new branch of AI. He had 2,000 lines of code, and then he trained the car based on his behavior how to drive. So we'll see many more examples of this. So how is all this data acquired? How do we get it into our organization? So drones and robots are a really big category that will probably only get bigger. On the lower, whoops, went too far ahead. That went really fast. So this photo down here on the corner is a drone with a LiDAR unit on it. So it can be used in natural resource management. So if you're going over a crop and you're looking for chlorosis, which is a yellowing of the leaves, you could have a LiDAR unit or infrared camera on it to detect that kind of stuff so you know precisely where to fertilize. It can be used for forest management. It can be used for surveying stream beds. There's lots of applications for LiDAR on a drone. The next one is Seattle Police Department. They're using drones there with cameras to help protect police officers. So if there's an altercation going on, if I can send up a drone and have an eye in the sky and understand what's going on before I send in some lieutenants to get murdered, you know what's happening. So you just have better information to be able to protect public safety, both for public and officers. The one on the right, this is not a real product yet. I think it's like a Kickstarter campaign. It's called the Pixie. It's a drone that wraps around your wrist and looks like a watch. And so with this drone, you just unfold it. You unfold it here, and then you just kind of throw it in the air, and it will, you configure it, and it'll stay like 20 feet in front of you. It focuses on you. So you can actually ride a mountain bike down a trail, and that drone is 20 feet in front of you, and it's filming you the whole time. There's a very small camera on this drone. You can see it in the little black dot there. So it's really interesting how this technology has expanded very, very rapidly in the last 5 years. The picture on the right is a guy with a virtual reality headset and a control in his hands. And this may be the future of some of your guys' jobs in this room. And the reason I say that is because this is a drone that is spray painting. So if you think about the Golden Gate Bridge, there's a huge effort underway continuously there to scrape off rust and paint. And so those are very dangerous jobs. People are walking way up high. It's windy, it's foggy. They're kind of shackled in so they make sure they don't fall off. If you can have a drone go up, do a little sandblasting, and paint, it's something that an individual person can avoid a dangerous situation. And so the way you do that is you combine AI that I talked about earlier with the drone. So this person here can train the drone to recognize rust spots and to paint over them, or to do a complete paint job. So it'll be a ways out before this stuff comes, but those are the things that we will have the capability of doing. And by the way, when this drone finds a rust spot, it catalogs it. It creates more data. So now we know where on that bridge there are susceptibilities to rust. We create this catalog which can be done, which we can use the data for more continuous inspections and for inspections on those particular areas. Drones can also be used to inspect bridges for cracks. It's much more effective to take a video or to use LiDAR to inspect a bridge or guardrails or other things than it is for have somebody to go outside and do it. So this is an example. I think the company is called Illuminations or something. It's a smart grid street light. So today, a lot of street lights are pretty dumb. They're just a light. A lot of them have been upgraded from sodium lamps to LED lamps. And some of them, like in Denver and certain places in the Bay Area, actually have microphones in them. This is today. And you can actually do gunshot triangulation. So if you have somebody shooting off a gun, you can triangulate where that's coming from, and you can send, safety officers there to find out what's happening to try to prevent loss of life from either that individual or somebody who's connected with them. But the streetlights of the future will have a lot of digital capabilities. So the light at the top, if you think about illuminating a street, if nobody's on the street, nobody's driving, nobody's walking, why do we have the street light on? We're just wasting energy. Now, there may be specific cases where you do want it on, but there's a lot of others where you don't. So you can have speakers in street lamps, which can act as a broadcast system if there's an emergency happening. These are signs here where if there's an emergency vehicle coming down the road, you can say, pull over. I've seen it time and again in Roseville where people just don't hear the ambulance or the fire truck, or they don't know the rules and they just keep driving and they don't really care. So it's public education. So wireless, mesh wireless network, you can provide that between all the signs, and then push to talk, so safety, kind of a call button. But there's a number of things you can do with these lights that can help actually save the public money and also improve the quality of life in neighborhoods. So the final kind of slide that matches up with my previous stuff on how do we acquire this data, I talked a little bit about the self-driving cars. They will generate tons and tons of data. Now, primarily that will be the domain of private companies. But the public will have an opportunity, depending on how the rules are written, to have access to that data. The one on the right, this is a robot called Baxter. And you don't write code to train this robot to do something. You actually train it by physically picking up the arm, moving it to the conveyor belt, clenching the claws, and then moving the arm back and dropping it in the box. So in about a day, you can train this robot to pack these parts in boxes. Very, very efficient. And if you're a human doing this task, it's pretty mundane, right? It's very repetitive, very prone to repetitive stress injury. So this is a great opportunity for a simple robot to be able to take over some pretty repetitive tasks. And finally did that again. Finally, in the upper left here is a terrestrial robot or drone. It's a concept. It's not for real yet. But if you think about trash on the sides of California freeways, especially in the Bay Area, there seems to be a greater amount of trash, probably because there's a greater amount of traffic. It's very dangerous to go out there and pick up trash. It's not a safe job for anybody. So if you can have a drone go out there and pick up trash, put it in a hopper, take it back to a base station, it's a huge safety element as well as a beautification of freeways. But just like the bridge example, now I'm going to have a record of what kind of trash I'm picking up. How much does it weigh? Is it toxic? Lots of different things. And I can communicate back out to the public saying, hey, you really need to tarp your loads. Or, we've noticed a change in trash on this particular freeway. Is there something that has changed that is causing that? So with this data, you can make better business decisions. So how do we build a durable architecture to accept all of this new data that's coming in? So this requires a little bit of technical talk about databases. On the left of the line, we have our traditional ACID-based databases. So every time I query it, I get the exact same answer. So they're very robust. They're relational databases. Everybody in the room is probably familiar with them. Examples are SQL Server and Oracle, Sybase, IBM, the typical suspects. The spatial databases, Oracle makes a spatial database. Esri is probably the most popular spatial database. And there's even a PostGIS, so a free spatial database that you can play with. On the right-hand side are all these new databases. So just because there's new databases does not mean that the ones on the left go away. Cassandra everybody probably has heard of Cassandra. It's what Facebook uses for a lot of their database analysis. MongoDB is a database store, and there's many in each category. These are just examples of them. Graph databases, and finally key value databases. These are mostly for websites if you're using JSON and REST interfaces. Key values are really good. So they all have their particular use cases, but they don't replace relational databases. All these databases are called NoSQL databases. They all run on Hadoop, and they're all eventual consistency databases, meaning that if I query 1 second here, and then I run the exact same query 1 second later, I may get a different answer. That's okay for a lot of use cases. But for a lot of use cases, it's not okay. So if you're running payroll or something, you probably don't want to have different paychecks going out if you're supposed to get the same paycheck every month. And at the bottom here, these are some distributors of those open source stacks. So Oracle has actually partnered with Cloudera. We have stuff that works on Hortonworks, MapR. If you want to really write some really heavy-duty code, you can use MapR. But there are other tools from many vendors that allow you to do things easier than with all of the open source tools. So this kind of makes the point that I was illustrating earlier. Conventional database or big data technologies. The gray line here is where a relational database has its strengths. And the red line is where a Hadoop-based database has its strengths. So they overlap in some places, but they're really complementary to each other. So a Hadoop database is cost-effective. It stores a lot of low-value data. It's just a server with a bunch of hard disks on it, and you just throw the data on it. A relational database is more expensive. So it's just ingestion rates. You know, Hadoop can ingest a lot of data because it doesn't do a lot of processing up front. With a Hadoop-based system, I'll go to the next slide. So this is information architecture. The row at the top here is a structured database, and here on the bottom is an unstructured. So a relational database, a traditional database, is a schema on write. So when I create a database, I have to create a table. It has some columns, and then I fill up all the rows. So I'm creating a structure, and then I'm managing the data, massaging it to go into that structure. So I have to do work up front before I get it into the database. And there's reference data, master data, transaction data. Those are the kinds of data that go into that kind of a database. We do some enterprise integration. I might write a query that runs across sales and HR and finance or something, put it into a data warehouse, and then I have some analytic capabilities. That's the very traditional route that most people are familiar with. The unstructured route, we don't do anything up front. We just dump it on a hard disk. There's machine-generated data. So this is sensors. We were talking with DWR earlier today out on the floor, and they're getting sensor data about weather monitoring stuff. Text, image, audio, video, web logs. We just dump all that data on a bunch of hard drives. So it's a distributed file system, that is Hadoop, and a key value data store, that's the database on top. And then we run a map-reduce job, which gives us the same value that we had when we started over here. So we sort of put off doing the work of bringing value to that data. Then there's a discovery lab. You can shove that into a data warehouse after you've done the map-reduce job, and then you get to your analytic capabilities. So they're different. Not one is better than the other. They're just best for different types of jobs. So a couple of use cases here. This is the digital experience. It's not wholly big data related. Actually, before this, I want to talk about a few examples that we have or I've been involved with at Oracle for big data. So we have a customer in New York State, happens to be the fire department, that is using big data to collect information from county records, from building permits, from age of the building, from vacancies. And they're pulling all this data together to target which are the houses that are most susceptible to loss of life. So they have a bunch of different analytics that they run through, and what they're looking for is if the firefighters go in and the building's been modified and they can't get through with their gear, or there's no window in a bedroom and somebody can't escape, let's go investigate those places and give them a violation basically so that we can protect loss of life. So that's one example. Another is in Washington, D.C., the Washington Sanitary Sewer District there. So they have pressure meters on all their water lines. And what they're doing is they're looking for water wasters or pipe breaks. So they were actually able to identify a particular customer, residential customer, that there was a leak in the backyard before the customer even knew about it. So the customer is happy because it saved them a bunch of money. They didn't have to pay all that wasted water. And the water district's happy because they didn't have to waste a bunch of water and process more water. We have another one right now. I'm working with the city of Denver on, it's a grant for smart cities. It comes from the Obama administration. And what we're trying to do is how do we move people? So if there's a major event in a city, we're working with Denver International Airport. We're working with RTD, which is a regional transit district, and we're working with a city. So if people are flying in for an event, or if they're taking trains, or if there's a concert, how do we move people most efficiently? And then how do we get them back to their hotels or back out of the city? Or if there's some sort of emergency event that happens, what's the best way to utilize the transportation network? And DIA, the airport, Denver International Airport, they've actually found, they're already doing some analytic capability, that the longer somebody waits in a security line, the less money they spend at the airport. And the airport is basically a revenue generating center. So they want to increase the revenue. And I think if you wait a half an hour, your spending goes down 20%. So it's really interesting. It's not something that you might necessarily suspect, but there are some really interesting use cases. And then in Phoenix, they have instrumentation on all of their trash trucks. So they know when the arms go up and down to dump a load. And what they found was there was some sort of rogue employees that were dumping trash for free. And so now they keep metrics on how often those arms go up and down to make sure that the city isn't collecting more trash than they should. So interesting. So this is the UK government. This is MHRA. It's the medical arm. They do some drug management as well for the country. And what their focus was really their interaction with their constituents. So outside in is customers looking into the government agency. We saw that a little bit in the talk this morning. How do we interact with the public? And inside out, how do we use that information and cultivate it within our organization to be a more effective interface to the public? So what's happened over time is that when you wanted to do like a building or something, you'd walk into the building office with a set of plans, and you would review them there. And then the other communication channel you had was maybe a letter, a written letter, or maybe there was a conversation at the desk. But that's changed. So now you can communicate with the building department through email, through text, through chat, through voice, through a call center. So what's happened is we've gone from a couple channels to a half a dozen or so. And when you have all these different conversations, they're not tied together, and you lose context. So what a platform like this does is it ties everything back together, and it allows you to query it. So if you have a call center and you notice that a certain customer keeps calling back in to lots of different departments, maybe there's an issue that you can help resolve. You don't want to waste your people's time, and you don't want to waste the customer's time either, or the person of the public. So this is what this looks like from an architectural view. It's a little bit of an eye chart, but at the top, these are kind of ways that we can interact with the public. And then this next line here is the digital front line. So we have marketing, which isn't, we wouldn't call it marketing in public sector. This is, of course, a non-public sector slide. Social relationship management. This is kind of the example of Nextdoor in the city of Roseville doing a lot of communication with their citizens. Commerce, so that could be the example of DMV, collecting registrations from people. It could be the courts that are collecting fees for court dates or something. It could be a lot of different things, and that's through a web browser or a phone. And then sales automation, there are some agencies, you go out to bid for stuff if you have a portal where everybody bids through the same way, or a person of the public that wants to know, okay, I want a CHP escort because I'm filming a movie in California along this road, how much is it going to cost me? They're trying to do bidding. Not bidding, but quote generation. And service, of course, a lot of agencies have call centers that help collect calls from the public. So the focus where we really want to focus, there's an integration layer here, which has identity management, security, that kind of stuff. But the real focus is down here on the information management. And this is similar to the slide before that showed I had structured on the top and unstructured on the bottom. So you can see there's kind of an event engine, data reservoir, which is your data lake, depends on what vendor you're from, who you want to call it. A data factory, which is where you do some analysis, and then you store it, and then you report out on it. So if I'm not tracking all of my customer or constituent interactions, I don't have any visibility to the whole constituent. I don't know. But once I implement this stuff up here, then I have visibility to this where I can make better decisions on how I'm spending money in my organization and how I'm interacting with the public. So Oracle has a reference architecture for this sort of digital experience. And this is it. It's a bit of it, it is really tiny. I don't expect anybody to read it. But what I really want to focus on is Oracle created a roadmap for MHRA. These are the things that are important to your organization out of this whole reference architecture. And then let's figure out a phased approach to do this. Because if you try to do everything at once, you will likely fail. So for phase one, they focused on the customer experience. So how are we going to interact with customers? We're going to have some forms. We're going to have caseworker workflow. So if you're in social services, you have a lot of case stuff that's coming out. Caseworkers take notes. They have conversations. How do we codify that, catalog it? How do we make it searchable? So that's what this part up here does. The red lines are new capabilities. The dotted ones are changing existing capabilities. And what we're interested in here today is the bottom, so data staging, data mining, information store. So in phase one, they just changed some existing functionality in data staging. And then in phase two, they changed out the staging area altogether, and then they modified some of the data mining. And that's a very typical progression. You can't do analytics on information you don't have. So the final example I want to go over today is Estapar. So this is a parking management company in Brazil. And they manage lots and lots of spaces. So they have 900 parking garages across 17 cities in Brazil, 22,000 spaces with 1,200 parking meters. So what they did is they developed a mobile app. And people can go into this mobile app, and you can read right down here. You can access rates. So they have variable rate pricing. They have hours the garage is open, the address. They have real-time information. And then they generate a bunch of reports on the back end that I'll show you in a minute. So they have a lot of users, a lot of payment transactions every month, and it's all through the app. So as you know, in emerging economies, they're more phone-based than they are desktop-based. So you'll notice a theme here. Again, it's phase one, phase two. They're kind of phasing in their project. So they have a vision or kind of a roadmap of where they want to go, and then they focus on the highest value stuff to get started. So initially, they wanted to understand, are people really using the app? You don't have to, but it just makes life more convenient. How are people using it? Where is it being used the most? What kind of revenue are we getting out of it? They're generating revenue. And then revenue loss reports and usage by car type or gender. So when you register with Estapar, you put in your sex, you put in your license plate number, you put in your home address, you put in the kind of car you're driving, the color of the car. So they have all this base data that they start to work with. And what this looks like from a back-end thing, they worked with Oracle, they used the mobile cloud service, they used the BI cloud service, and then they had an on-site database where they kept all their information. So the mobile back-end service kind of handles a lot of the plumbing for their app over here, and the BI cloud service does the reporting out of it. So this is a revenue report that they get out of the system. So you can see it's 190,000 probably reals. They're generating the most revenue from Sao Paulo. The next biggest revenue is Rio de Janeiro. And you get a map here with kind of the size of the circle represents how much revenue is coming from that area. So it's very visual. The next slide is parking duration. So how long are people parking? Because that can affect your business decisions about how you charge rates. So here, it may be hard to read. It's about 20 minutes, the average parking time. And then they have parking times, you know, kind of, it's like a word diagram. And again, they have it's 36 minutes, and I guess that's Sao Paulo. So they park a little bit longer in that city for some reason. It may be where the parking garages are located. It may be that it's really commuter-based, so they're parking their cars there for longer. Then they have a violation report. So where are most violations happening? It makes sense that where they generate the most revenue, they probably have the most violations because they have a lot of traffic there. But the company probably doesn't want to issue a lot of violations because it doesn't make for a happy customer, somebody who's using that service. So they can look at analytics to figure out, okay, how do we alert people so that they don't make a violation? And actually in the app, it will tell you, it will buzz you like 10 minutes before your parking expires that, hey, your meter's going to run out. You better go fill it up or move your car. So they are trying to do some preventive stuff to help, because they want people to use the system the most efficiently. If somebody stays over their time, then they can't predict that that spot's going to be open for somebody else to come in and grab it. So this is probably the most interesting one. This is actually my last slide. So this is Estapar user type report. So I found it very interesting that 68% of the folks that use this system are women. Only 32% are men. You can see the most common payment method is Visa and MasterCard, a little bit of American Express. And you can also see the different car types here. The only one that folks in the room probably would recognize, this is a Ford Fiesta. So that seems to be a pretty popular car. And then I think this is a Toyota Sienna or something. The other ones are brands that we wouldn't recognize. But it gives you this really good view of your organization, or in this case, your business. So if you had this kind of data as a state or city or county organization, it really helps you make good decisions. So in conclusion, the scope and the value and the definitions of big data will continue to evolve. And what I've noticed over the last, I think it's been 2.5 years now, is that the definitions of big data have broadened. And they've shifted from mostly Hadoop-based conversations to more analytical-based conversations, which is good because you're focusing now on the business value that you're getting out of this implementation that you're doing. It's not a science project anymore. It's really talking about how do we get value out of it. So value is really found in combining data sets and analytics. If you're just looking within a single data set, it's pretty hard to get much value out of it. You have to marry different data sets together and then draw conclusions across that. And then new data sources will require new tools. So if LiDAR becomes important for your organization, you're going to have to probably implement some sort of spatial database to support that, and then be able to marry that data with relational data that you already have in your organization, or other data sets, maybe web logs or something that are coming in. Big data complements existing technologies rather than replace them. So it's a little bit, I've talked with some customers, and they believe that Hadoop-based NoSQL databases can replace all of their relational databases. Relational databases are not the cheapest databases around, so there's an economic incentive to do that, but it just doesn't work for most use cases. So big data must be integrated. Successful projects will identify those key use cases to be successful. So if you try to do too much, and this was very common when data warehouses first came out in the mid-90s, people tried to give reports to every organization in their company or every department in their public sector organization, and it failed. You have to start with some specific use cases. And then, of course, big data is rapidly evolving. So it's continuing to change. So with that, that is the end of my presentation. It is 10:55, so we have time for probably 5 minutes of questions for either Gil or myself.
Any questions from the audience? Don't be shy.
Yeah.
On your list of like emerging technologies, you had a lot of technologies, and you showed the light bulb, which was
Yeah.
kind of an IoT. You really didn't talk much about IoT for big data and capture information. And one thing I'm finding with some of the things we do is there's not a lot of IoT in devices, things that actually capture the data. Are you experiencing that, or are you seeing an emergence of it?
No, if I go back to that slide, that manufacturer, they actually provide a REST interface to interface with a Hadoop-based database to capture the data. So you'll still have to write the integrations that go from that to your relational data or for doing reports. So it doesn't sort of obviate the need to still do some work, the integration part. Did I pass it? I didn't talk about light dimming, so at night you probably don't need the lights as bright at certain times as you do at others, so that's another way to save energy. But we do a lot of IoT, like the example of the sewer district, so water sewer district. Those are all sensors, pressure sensors that they have on all of their pipelines. So all that data gets transmitted wirelessly, and it's just, it's a date time stamp with the pressure reading, and that's it. You can just shove that into valued pair database on Hadoop, and then you can query across it, and then you can create reports using like Spark if you want to do real-time stuff, and then push it into a relational format where you can actually do the processing in real time. But even the garbage truck example, that is, it's a sensor on an arm, right? But there still is that integration work that has to be done between I have this data, and I have to give value to it through formatting it. Thank you. Yeah. Yes, I've sent a PDF copy to Sherilyn, so I don't know how they get distributed. They may be available on the app already. I sent it this morning, so I haven't checked. But that's my understanding that they will be available. This is being video recorded, or it was being video recorded, so it's supposed to be available on YouTube in about 2 weeks. So you can watch it again, you can pause, and you can kind of see different things. So that's a good question. Thank you. All right, thank you guys.